Let's look at the models and characteristics of cloud computing. So it's basically something like this: how to turn some resource, for example, this water, drinking water resource, and turn that into a more user friendly or more convenient and a sort of a service that is way better than the primitive way of it, um, or something like this electricity production, turning the old way into a way that is way more convenient. And also there are many more other characteristics or advantages that we will discuss, right? So taking a service or resource and then turning that into something more convenient and having many more advantages that we are going to discuss. So why do we turn to cloud computing? Similar to what I just mentioned from the previous slide, how to take resources that we already have and then make it more convenient, or uh, have many more advantages such as agility, such as high availability and reliability, such as high scalability. So high scalability deals with making it, multi-shared, device and location independence, easy maintenance, lower cost. That means for any IT company, we need a server room. That is the basic need of IT companies, right? How to reduce that cost. So with cloud computing, we end up having lower cost um, to meet demands like this. And also services in pay-per-use mode, just like other utilities. Just like we have electricity, we only pay for how much electricity we use. We don't need to worry about how much electricity the provider is, generating. We don't have anything to do with that. We just pay for what we use. So making cloud computing be pay-per-use. So for example, let's look at electricity. So a utility like electricity supply. Um, if we have a personal electricity generation, what do? Your power generation is fixed, right? Depending on your generator, you produce a such or you generate a fixed amount of power regularly. You may need less than your generation, right? So that ends up in a lot of wastage. If you only have a very big generator, and you switch it on, you may not be using all the electricity that it is generating, but it will be running. It will be using the fuel as normal, and you may be using very little of the electricity that it is producing, right? Um, Also, sometimes you may need more than your fixed generation. So your generator might be generating certain, you know, some electricity, but maybe there is an event taking place at your house, and suddenly you need way more electricity supply, and your generator cannot provide that much. So you could have wastage, you could have shortage if you are set up to supply your own electricity. Whereas if you compare to getting electricity from a service provider, right? If you need less electricity, you you uh, you just use whatever you need, and you don't need to worry about any excess, or if the provider is producing or generating more electricity and is going to waste and all that stuff. You as the user does not have to worry about any of that. Also, if you need to use more, you just use more. There's this You have nothing to worry about, regarding how much is being produced on the service provider's side. If you need less, just use less, and you don't have to pay any extra. If you need more, just use more, and you just pay based on how much you use. Right? So that's pay on your usage. So that having a service provider makes it very convenient and advantageous to the user. Right, so let's look at an articulation of cloud computing here. Cloud computing is a general term for the delivery of hosted services over the internet. Cloud computing enables companies to consume compute resources as a utility, just like electricity, rather than having to build and maintain computing infrastructure in-house. Cloud computing promises several attractive benefits for businesses and end users. Three of the main benefits of cloud computing include self-service provisioning. Right? So self-service provisioning is end users can spin up computing resources for almost any type of workload on demand. And we will be looking closer at these later in the semester. But self-service provisioning is something very useful. For example, if I am a user and I want to run some code, I have some very compute heavy program that I want to run for maybe some experiment that I'm trying to run. Um, and I don't have the PC specs that's required to run that code. So I can go to AWS, I can go to Google or IBM or Microsoft, and I can try to get the database or the compute power, the CPUs that I require to run my particular program, right? So that's what we mean by end users can spin up computing resources for almost any type of workload on demand. And then there's another benefit, which is elasticity. So companies can scale up as computing needs increase and then scale down again as demands decrease, right? So for example, if um, if it's, let's say, holiday season and you have a tourism company or something like that, and your business really thrives during the holiday season, and you need extra resources at just that time of the year only. So you can increase your need, your resources just for that time and scale down again once it is downtime for your business. So that's elasticity. And then you have pay per use. Computing resources are measured at a granular level, allowing users to pay only for the resources and workloads that they use. So just as we looked at the electricity, the generator, and um, electricity provided by a service provider, that example, right? So pay per use, you only pay for what you use. Some characteristics of the cloud. So, an IT environment requires a specific set of characteristics to enable the remote provisioning of scalable and measured IT resources in an effective manner. These characteristics need to exist to a meaningful extent for the IT environment to be considered an effective cloud. The following six specific characteristics are common to the majority of cloud environments. So, as you can see in this statement, there's no, you know, qualifying grounds, let's say. Uh, yeah, there's no defined qualifying grounds for an IT environment to be called cloud, right? There are some characteristics that should emerge out of the setup, the IT environment that is there, which would then make it an effective cloud, or it could be an ineffective cloud, or it could be just a very small setup which doesn't really qualify as cloud. Right? So what are the characteristics, the common ones that majority of cloud environments include? So these characteristics include on-demand usage. So when the users need more, the cloud environment should be able to provide more, and if they need less, they should easily be able to just use less, right? So that's one characteristic. Then you have ubiquitous access, meaning it should be able to users should be able to access it from anywhere. Multi-tenancy or resource pooling, and also elasticity or scalability, and measured usage and resiliency. And so these are some characteristics. Let's take a closer look at these. So on-demand usage, what is this about? A cloud consumer can unilaterally access cloud-based IT resources, giving the cloud consumer the freedom to self-provision of these IT resources. All right, so as I said, if I want to run my code and I need more powerful computer, I can get access to that through AWS. I just pay and get the specific storage space that I need, the specific CPUs that I need. All right, so that is on-demand usage. Once configured, usage of the self-provisioned IT resources can be automated, requiring no further human involvement by the cloud consumer or cloud provider. This results in an on-demand usage environment, also known as on-demand self-service usage. This characteristic enables the service-based and usage-driven features found in mainstream clouds. Then we have the characteristics of ubiquitous access. So ubiquitous access represents the ability for a cloud service to be widely accessible, right? Ubiquitous meaning from anywhere. Establishing ubiquitous access for a cloud service can require support for a range of devices, right? So a range of devices meaning if the user is to access it from anywhere, they probably should also be able to access it from any device. Let's say a tablet or a desktop computer, a laptop or a smartphone. Transport protocols need to be sorted, interfaces need to be sorted, and security technologies need to be taken care of. Right, so establishing ubiquitous access is quite and quite challenging for the cloud setup, right? Because you need to look into a lot of things like these, the range of devices, transport protocols, interfaces, and security technologies. To enable this level of access, generally requires that the cloud service architecture be tailored to the particular needs of different cloud service consumers. And then you have multi-tenancy and resource pooling. So basically, resource pooling allows or helps in providing multi-tenancy, right? So for example, in multi-tenancy, you have a storage cloud, a shared cloud, which it is shared because many consumers can access this service, right? And you have a storage device that is providing cloud service A and cloud service B, and then you can have multiple consumers consuming the particular cloud services. Or you can have single tenant resource pooling where you have cloud storage A device A and cloud storage device B, and each of the devices have a cloud service associated with them, and then cloud service consumer A and B access the particular services. Right, so multi-tenancy meaning on from each cloud you can accommodate multiple consumers. The characteristics of a software program that enables an instance of the program to serve different consumers or different tenants, whereby each is isolated from the other, is referred to as multi-tenancy. So here the tenants do not engage with each other, or they do not interfere with each other. They're completely isolated. The cloud provider pools its IT resources to serve multiple cloud service consumers by using multi-tenancy models that frequently rely on the use of virtualization technologies. And we will look at virtualization technologies later in the course. Multi-tenancy technology is used to dynamically assign and reassign IT resources according to the consumer's demands. Resource pooling allows cloud providers to pool large-scale IT resources to serve multiple cloud consumers. So resource pooling is commonly achieved through multi-tenancy technology and therefore encompassed by this multi-tenancy characteristic. So resource pooling and multi-tenancy they go together. And to enable all of that, we have virtualization. So all of these concepts are linked, but you need to be able to to understand what they are talking about, what each concept means on its own. um, anyway, the characteristic of elasticity. So elasticity is the automated ability of a cloud to transparently scale IT resources as required in response to runtime conditions or as predetermined by the cloud consumer or cloud provider. We will go deeper into each of these things, but just for now, I hope you can understand, like an overview, that elasticity. This is another characteristic, and this is basically talking about being able to expand or reduce what the user um, gets to use, either uh, depending on whether the user demands it, or if the cloud provider has set it up in that way, predetermined in that way. Elasticity is often considered a core justification for the adoption of cloud computing, primarily due to the fact that it is closely associated with the reduced investment and proportional cost benefit. Right? So basically talking about not wasting, so only signing up for what you need, which reduces your the user's expense. Cloud providers with vast IT resources can offer the greatest range of elasticity, right? So I hope you can understand why this would be so. Right, so cloud providers with uh, greater IT resources, with more resources, they can offer the best or the biggest range of elasticity, because if you have a lot of resource, you can always just provide less and not and not provide all of them. Have them but not have them up for use, and have them up for use only when needed. But if you are a cloud provider and you don't have, your IT resources aren't that vast, then you can always provide less, but you cannot provide more, right? When you have to expand it, you cannot do that. Then we have the characteristic of measured usage. The measured usage characteristic represents the ability of a cloud platform to keep track of the usage of its IT resources, primarily by cloud consumers. So based on what is measured, the cloud provider can charge a cloud consumer only for the IT resources actually used, and or for the time frame during which access to the IT resource was granted. Right? So based on what's being measured, either the time, how long did you use this service, or how much did you use this service, like how many, if it's a database, if it's storage, right, then you could be charged on, or you um, yeah you the provider could be measuring how much space you're using and charge based on that. Like if you're using 1 terabyte, then they charge you a certain amount. If you're using 500 gigabytes, then they will charge less, and so on. Or um, how long are you using this service for, based on time. If you're using for a longer period, you get charged more, etc. Measured usage is not limited to tracking statistics for billing purposes. It also encompasses the general monitoring of IT resources and related usage reporting for both the cloud provider and the cloud consumers. Another characteristic of cloud computing is resiliency. So, resilient computing is a form of failover that distributes redundant implementations of IT resources across physical locations. So, on purpose, redundant implementations are made available. to make sure to make sure the services are always available when users need them. So IT resources can be pre-configured so that if one becomes deficient, let's say one server goes down, processing is automatically handed over to another redundant implementation. Within cloud computing, the characteristic of resiliency can refer to redundant IT resources within the same cloud, but in different physical locations or across multiple clouds. Cloud consumers can increase both the reliability and availability of their applications by leveraging the resiliency of cloud-based IT resources. So a resilient system could look something like this. Let's say you have cloud service A and being provided here, and the consumer cloud service consumer A is using this cloud service. Um, Now, the provider could have a redundant implementation of the same service available somewhere else. So, this was available in Cloud A. However, this is available in Cloud B as like a backup, right? So, this is the resilient failover system. So, as if Cloud Service A goes down for whatever reason, um, the cloud service consumer A can easily just switch to the redundant implementation that was already there. Um, they may or may not know that they have actually switched. Right, so key cloud benefits. What are some benefits of using the cloud? Firstly, you have huge resources. So IT agility as systems can be sized to meet the demand. As load scales, system resources are easily obtained to ensure your service level, not SLAs. Oh God, okay, let's do this again. So there are many benefits to using the cloud, and the key benefits are mentioned here. So firstly, there are huge resources. So IT agility as systems can be sized to meet demand. So as load scales, system resources are easily obtained to ensure that the service level agreements can be met. Another benefit is no commitment. So no longer face to trade-off between over provisioning or waste of capital and under provisioning, such as waste of users, right? So there is no commitment. If you need more, you just get more, and if you need less, you use less without wasting or losing your users or without wasting money. Right. Another benefit is pay as you use. So here you move your IT payments from capital expenditures to operating expenses only, right? So you don't have to worry about buying the big computers. You don't have to worry about buying the servers. You just have to worry about using the servers. You pay only for actual resources that are consumed. It ties the IT cost to business benefit received. Okay, let's look at the cloud roles now. So there are 7 primary roles in cloud computing. You have the cloud provider, consumer, the cloud service owner, the cloud administrator, cloud auditor, cloud broker, and cloud carrier. Who are the cloud providers and consumers? So the cloud provider is the organization that provides the cloud-based IT resources. Okay, the resources could be things like the computer, the the databases, and so on, right? The network infrastructure and so on. So that is the cloud provider. Then you have the cloud consumer. This is an organization or person that uses the IT resources provided by a cloud provider. It holds a formal contract or agreement with the cloud provider for this purpose. Right, so you have the let's say the cloud provider here providing cloud aid, which has some cloud service, and then you can have the cloud consumer, which could be an organization or a person that is using the IT resources provided by the cloud provider. Then you have the cloud service owner. This is the person or organization that legally owns a cloud service and is called a cloud service owner. Right, so this looks something like this. You have the cloud consumer, and you have the cloud provider, and you have cloud X provided, the resources provided by the cloud provider. And then you have cloud service owner, which can be the cloud consumer or it could be the cloud provider, right? So either of them could own the cloud within which the cloud service resides. Right, so it could be the cloud consumer that is owning this service or the cloud provider that is owning that service. Next, we have cloud resource administrator. So this person is responsible for administration of a cloud-based IT resource. Could be a cloud provider or cloud consumer again, right? So the resource administrator could be either of those. In this diagram here, the cloud consumer's resource administrator remotely accesses the virtual server hosting cloud service A, which is owned by the cloud consumer. Right, so we have Cloud X and we have the cloud provider providing the resources that create this Cloud X, right? And we have a consumer. The cloud consumer is actually has the cloud resource administrator, right? Using the cloud, the resources that are provided by the cloud provider in this cloud, and they're using the resource to host or to to host some cloud service, and so the cloud service is owned by the cloud consumer. We have some additional cloud roles like the auditor, right? So the cloud auditor, a third party often accredited that conducts independent assessments of cloud environments, assumes the role of the cloud auditor. The typical responsibilities associated with this role include the evaluation of security controls, privacy impacts, and performance. The main purpose of the cloud auditor role is to provide an unbiased assessment of a cloud environment to build a trustworthy relationship between consumers and providers. Then we have the cloud broker. This role is assumed by a party that assumes the responsibility of managing and negotiating the usage of cloud services between cloud consumers and cloud providers. And we have the cloud carrier. So the party responsible for providing the wire level connectivity between cloud consumers and cloud providers assumes the role of the cloud carrier. This role is often assumed by network and telecommunication providers.